Why, hello, new scientists of the world. Welcome to Biology 101 with Dr. Rizzoli. Do you feel like ripping your hair out every time you hear thermodynamics? Well, we're all going to stay like protons and be positive because by the end of this video, you're going to know thermodynamics inside and out. Instead of me just endlessly talking to you about it, let's get some visuals.
Ah, now that's better. Now first, we gotta learn the 3 laws of thermodynamics. Law 1, or the conservation of energy law. Energy cannot be created or destroyed. It can only be transferred from one form to the other. We got a handy equation here that says any change in internal energy of a system is the sum of the heat flow and the work done. Now you're probably wondering, who even cares? Well, this applies to our metabolism. The heat transferring out of our body, Q, and the work done by our body, W, uses energy. Then with food, the used energy is replaced. When we eat something like bread, a starch, we are mostly intaking the sugar glucose. When we eat bread, a thing called catabolism starts breaking down those long chains of starch so the glucose can travel through the body. We also have something called ATP that stores energy and can travel to wherever energy is needed in the cell. ATP relies on glucose to keep it running. With this energy, the body uses anabolism to then rebuild those nutrients. When the rebuilding is occurring, the molecules go into a high energy transition state, so they become unstable, resulting in them reforming. And this is how our bodies grow. Now, law number 2, that says there is disorder within the body driven by different types of reactions, where the entropy either remains the same or increases. Now, don't panic when you hear this word entropy. All it means is the measure of disorder within a system. From what we know, the body needs energy, but when there's an excess, the body releases it in the form of heat, like when we sweat. But be careful, don't get this word confused with enthalpy. That means the total energy within a closed system. Now, the universe uses this released heat to make itself more disordered. If our body did not always strive to be orderly, there would be so much heat and disorder in our body that we would die. However, the universe strives for disorder because it does not require any work. So basically, the world is really lazy. But think about it this way. If you have a clean room, it would take work to make it orderly. However, it's just so much easier if you just put everything on the floor and then create disorder. Okay, last but not least, we got the 3rd law, which states that entropy of a system approaches a constant value as the temperature approaches absolute zero. That's in kelvins. The entropy of a perfect crystal is at absolute zero. Take a look at the picture to get a better idea with more familiar temperatures. Alright, now on to Gibbs free energy. All it means is the available energy to do work. When we have something called spontaneous or exothermic reactions, a reaction releasing energy. The process of metabolism is a spontaneous reaction because energy is released to fuel our bodies. With the Gibbs free energy equation, the change in free energy is the total energy changed minus the temperature times the change in energy lost to entropy. Again, this is used in our metabolism when we are breaking down and rebuilding those nutrients. When the molecules go into the high energy transition states, the molecules are unstable and have enough energy to then reform. With all this talk about energy, there's a couple things that we quickly need to go over. Exothermic reactions are when the reactants have higher energy states than the products, and an endothermic reaction is when the reactants have lower energy states than the products. There's just one last thing for you to know until you can be called an expert, and that is metabolic disequilibrium. Our bodies are never able to reach equilibrium or a state of balance. However, if this were to happen, the Gibbs free energy of a cell would be 0 and the cell would die. And then you could put together what would happen to us if that ever happened. What keeps a cell alive is the fact that it is an open system and it is constantly reacting with things. Energy couplings, or the transfer of energy from catabolism to anabolism, leads to metabolic disequilibrium. Since the catabolic reactions power the anabolic reactions, through this energy coupling, the cell always has enough energy to keep doing work and stay alive, and hence humans exist.
Now you can officially be called Master of Thermodynamics.